Imagine a helmet so brilliantly designed that modern ballistic engineers study it today, yet it was forged over 2,000 years ago without computers, without advanced metallurgy, without even basic physics knowledge. A piece of armor that could deflect a sword strike traveling at 70 miles per hour, absorb the impact of a war hammer, and still allow the wearer to hear enemy footsteps behind them. But the world of ancient warfare holds far more than simple metal caps strapped to heads. These weren't just protective gear. They were the difference between a civilization's survival and its extinction. Buried deep in archaeological sites across every continent, researchers have unearthed helmet designs so sophisticated that they incorporated principles of shock absorption, weight distribution, and trauma reduction that wouldn't be officially discovered by science for another millennium. Some were covered in designs so psychologically terrifying that enemies would flee before the first sword was drawn. Others were engineered with ventilation systems more effective than medieval armor made 800 years later. Helmet 1. The Corinthian Helmet. The Corinthian Helmet. Just hearing that name, you might picture something elegant, classical, museum-worthy. But here's what the history books don't tell you. This helmet was so effective at keeping Greek warriors alive that it remained in use for over 300 years. 300 years. In a time when military technology evolved rapidly, when every generation brought new weapons designed to pierce, crush, and shatter, this single design kept working. Forged around 700 BCE, the Corinthian helmet covered almost the entire head, cheeks, nose, everything except the eyes and mouth. But here's the genius part that saved countless lives. It was hammered from a single sheet of bronze. No weak points. No seams where a blade could slip through. No rivets to fail under impact. One piece of metal, curved and shaped with such precision that it could deflect a spear thrust that would have otherwise gone straight through your skull. Now, you might be thinking, full face coverage sounds suffocating, right? Here's where it gets interesting. The Greeks who designed this understood something about combat psychology that modern studies only confirmed in the 1970s. When a warrior can't see your face, can't read your expressions, can't tell if you're afraid, you become less human. More terrifying. The Corinthian helmet didn't just protect the body, it weaponized anonymity. Imagine hundreds of bronze-faced warriors advancing in formation. No faces, no fear visible, just metallic death marching toward you. But there was a critical flaw that nearly made this design obsolete. The hearing problem. Soldiers wearing Corinthian helmets were essentially deaf. The bronze covered their ears completely. In the chaos of battle, where your life depends on hearing a sword swing from behind or a warning shout from a comrade, this was potentially fatal. So why did it remain popular for centuries? Because Greek warfare wasn't about individual duels, it was about the phalanx. Soldiers fought shoulder to shoulder in tight formation. You didn't need to hear the enemy behind you because your brother-in-arms was there, and he had your back. Literally. Here's the detail that makes this even more fascinating. Archaeologists have found Corinthian helmets with customized modifications. Some have small holes drilled near the ears. Others have the cheek guards bent outward slightly. These weren't manufacturing defects, they were personalized survival adaptations. Warriors who survived long enough learned exactly how to modify their helmets for their fighting style, creating what we'd today call custom combat gear. And the psychological impact? Ancient writers recorded that when Greek hoplites removed their helmets after battle, enemies were often shocked to see young men, sometimes teenagers, beneath what they'd assumed were hardened killers. The helmet aged them, made them mythical. But as brilliant as the Corinthian design was, another civilization was developing something even more advanced. A helmet that could actually move with the wearer's head. Helmet 2. The Chalcidian Helmet. The Chalcidian helmet appeared around 600 BCE, and it did something revolutionary. It gave soldiers their hearing back without sacrificing protection. But how? That's the engineering marvel we're about to unpack. Named after the Chalcidice region in northern Greece, this helmet kept the full facial protection of the Corinthian but added large, curved cutouts around the ears. Seems simple, right? It's not. These weren't random holes. The cutouts were precisely positioned and shaped to allow maximum sound transmission while maintaining structural integrity. Engineers today call this strategic material removal, taking away metal to improve performance without weakening the structure. Here's the insight that changed ancient warfare. Sound awareness equals survival. The Chalcidian design acknowledged that a soldier who can hear lives longer than one who can't, even if is slightly more vulnerable to a perfectly placed strike to the ear area. And here's the statistical reality from ancient battles. Glancing blows to the side of the head were far more common than precise thrusts to the ear hole. So the trade-off made mathematical sense. But there's something even more intriguing about this design. The Chalcidian helmet featured hinged cheek guards. Stop and think about what that means. Over 2,500 years ago, craftsmen were incorporating moving parts into combat armor. The cheek guards could swing down for maximum protection during battle, then swing up when the fighting paused, allowing the warrior to drink water, eat, or simply breathe easier. This was early modular armor, adapting to the situation in real time. And here's a detail that shows the sophistication of ancient metalworkers. The hinges were engineered to be stiff enough that they wouldn't bounce open during combat, but loose enough that a warrior could open them with one hand while holding a weapon in the other. That's precision engineering with Bronze Age tools. Now, archaeologists have discovered something else interesting about Chalcidian helmets. Many have reinforced brow ridges. These weren't decorative. They were specifically designed to deflect downward sword strikes away from the face. A blade coming down would hit that ridge and slide off to the side rather than crushing into the skull. This is reactive armor design, shaping metal not just to block but to redirect force. But here's where military strategy enters the picture. Chalcidian helmets were expensive. Far more expensive than Corinthian helmets because of the additional craftsmanship required for the ear cutouts and hinged guards. Only wealthy soldiers could afford them. This created a visible class distinction on the battlefield. You could literally identify the richest, most experienced warriors by their helmets. And enemies knew it. Taking down a soldier in a Chalcidian helmet meant looting high-quality gear. It made these warriors priority targets. Yet the design spread across the Mediterranean, adopted by multiple civilizations. Why would everyone copy something that made you a target? Because it worked. Because soldiers who wore them survived at higher rates, regardless of the target on their heads. But as Greek helmet technology was evolving, another empire far to the east was creating something that would redefine head protection entirely. A helmet made from a material that shouldn't even exist. Helmet 3, the Persian bronze scale helmet. Persia. The word alone conjures images of vast armies, immortal warriors, empires that stretched from Egypt to India. And their helmet technology? It was unlike anything the ancient world had seen. Around 500 BCE, Persian metalworkers created helmets covered in small, overlapping bronze scales. Not solid metal. Not plates. Scales. Hundreds of tiny bronze pieces, each one attached individually, creating a surface that could flex and move. But here's the question that modern researchers obsessed over. Why would anyone go through the painstaking process of attaching hundreds of small scales when you could just hammer out a solid helmet? The answer is biomechanics, though the Persians didn't call it that. When a weapon strikes solid metal, all the force transfers through the rigid surface directly to your skull. It's basic physics. But when a weapon strikes scales, the individual pieces shift, absorb, and distribute the impact across multiple points. The scale that gets hit moves, pushing against its neighbors, which push against their neighbors, creating a ripple effect that dissipates energy. It's the same principle modern body armor uses with overlapping plates. But here's the genius detail that shows how advanced this thinking was. The scales weren't all the same size. Archaeologists examining intact Persian helmets discovered that the scales on the crown, the top of the head where blows are most common, were smaller and more densely packed. The scales on the sides and back were larger and more loosely attached. Why? Because the top needed maximum impact resistance, while the sides needed flexibility for comfort and movement. This is adaptive engineering. Customized protection zones on a single piece of armor. And there's something else that makes this design remarkable: repairability. If solid bronze helmet gets dented or cracked in battle, you need a skilled metalworker and significant time to fix it. But if scales on your helmet get damaged, you just replace those scales. Soldiers could carry spare scales in their equipment and make field repairs. This is sustainable warfare technology, armor that doesn't become useless after one battle. Now here's where it gets psychologically interesting. The scales created a distinctive sound when the wearer moved, a soft, metallic whisper. Ancient accounts describe Persian armies approaching like a bronze serpent sliding across the desert. That wasn't poetic exaggeration. Thousands of soldiers in scale armor created an acoustic signature that preceded them, a psychological weapon that announced their arrival before they could be seen. Terror has a sound, but the Persian design had a critical vulnerability that enemies eventually learned to exploit. The scales were attached with wire or cord threaded through small holes. A precise thrust with a narrow blade, like a Roman gladius, could slice through the attachment points, causing scales to fall away. Suddenly, your ingenious protective system had a gap. And in battle, one gap is all it takes. Yet the design was so effective that variations of scale armor continued to be used for over 1,000 years, spreading from Persia to Rome, from Central Asia to China. That's not just success, that's revolutionary. But speaking of Rome, they were watching all these designs, learning from them, and preparing to create something that would dominate the ancient world for centuries. Helmet 4, the Imperial Gallic Helmet. The Romans weren't innovators. They were perfectionists. They looked at every helmet design across the ancient world, analyzed what worked, stripped away what didn't, and created what might be the most practical combat helmet ever forged before the modern era, the Imperial Gallic Helmet. Developed around 50 BCE, this helmet did something unprecedented. It protected everything while sacrificing nothing. Full head coverage? Check. Hearing ability? Check. Vision? Check. Comfortable enough to wear all day? Somehow, yes. But here's the specific feature that shows Roman engineering brilliance. The neck guard. That downward-sloping piece of metal at the back wasn't decorative. It was a calculated defense against the most common battlefield kill, the strike to the back of the neck. Roman military analysts, yes, they had analysts, studied battlefield casualties and found that soldiers were most vulnerable when turning away or retreating. A downward sword stroke to where the spine meets the skull was almost always fatal. So they extended the helmet backward and downward, creating a sloped surface that would deflect those strikes away from the vulnerable area. Now here's where it gets even more sophisticated. The helmet featured embossed eyebrows, raised ridges above the eye openings. Why? Because when a sword strikes downward toward your face, it follows the contour of your head. Those embossed ridges would catch the blade and channel it outward, away from your eyes. This is three-dimensional defensive thinking, designing not just to block impacts but to redirect them along planned paths. But the Romans understood something else that earlier civilizations missed. Comfort equals combat effectiveness. A soldier who's distracted by an uncomfortable helmet, who's constantly adjusting it, who gets headaches from poor weight distribution, that soldier fights worse. So the Imperial Gallic helmet included a padded liner system. Leather padding inside, suspended by cords, creating a gap between the metal and your skull. This did two things. It absorbed impact force, and it allowed air circulation. Your head stayed cooler, you were more alert, and blows that would have caused concussions were partially absorbed by the padding system. And here's a detail that shows Roman organizational thinking: standardization. Earlier civilizations made custom-fitted helmets for each warrior. The Romans created size categories: small, medium, large. This meant faster production, easier replacement, and the ability to quickly arm vast numbers of soldiers. It's ancient mass manufacturing. But before moving on, I would like to ask you for something. If you enjoy these documentaries and want to support me, please consider subscribing. It's free. Now, there's something darker about the Imperial Gallic helmet's effectiveness. Roman legions conquered most of the known world, and this helmet was on their heads while they did it. When archaeologists excavate ancient battlefields, they find the skulls of Rome's enemies, crushed, broken, cleaved. And they find Roman skeletons with their Imperial Gallic helmets still intact, often undamaged. The casualty ratios weren't even close. This helmet, combined with Roman training and tactics, created such a survival advantage that it bordered on unfair. And here's the evolution that proves its effectiveness. The design barely changed for over 300 years. In an era when military technology constantly evolved, when every generation brought innovations, the Imperial Gallic helmet remained essentially the same from 50 BCE to 250 CE. Why? Because it was already optimal. Roman engineers tried to improve it and found they couldn't without making trade-offs that reduced effectiveness. But while Rome dominated the West, warriors in the frozen North were developing something that would eventually help bring down the Roman Empire. A helmet built for a completely different style of warfare. Helmet 5, the Vendel-era helmet. Sweden, 600 CE. The Viking Age hasn't begun yet, but something is brewing in Scandinavia. A warrior culture is developing, and their helmets tell a story of violence, craftsmanship, and psychological warfare that historians are still piecing together. The Vendel-era helmets, named after a Swedish archaeological site, featured something that earlier European designs lacked: full face masks. Not just cheek guards or nose guards. Complete metal faces, often depicting animals, demons, or ancestral warriors. But here's what makes this fascinating from a life-saving perspective. The masks weren't just decorative terror devices. They were structurally integral to the helmet's protective capability. By extending metal coverage over the entire face and shaping it with ridges and curves, the design created what engineers call a crumple zone. space between the metal and your actual face where impacts could be absorbed. A sword strike to the mask would dent the metal, but the force would be distributed across the entire structure rather than transferring directly to your facial bones. Think about what this means in practical terms. A strike that would shatter your jaw or crush your nose hits the mask instead. The mask deforms, absorbing energy. Your face, behind it, remains intact. This is proto-modern helmet design, creating buffer zones between threat and body. Now here's the detail that shows sophisticated metallurgical understanding. These helmets weren't made from uniform metal. Archaeologists using modern analysis techniques have found that different parts of Vendel helmets were made from different iron alloys. The crown, the top of the head, was made from harder, less flexible metal because it needed to resist direct impacts. The mask and cheek guards were made from slightly softer, more flexible metal because they needed to absorb and distribute force. This is material science in action, 1500 years before it would become an official field of study. But there's a psychological dimension that's equally important. Imagine you're in battle, and you're facing an enemy whose face you can't see. Not because it's covered in darkness or shadow, but because they're wearing the metal face of a boar, or an eagle, or something that looks like death itself. You can't read their expressions. You can't tell if they're tired, or afraid, or about to strike. Every warrior becomes an identical, inhuman threat. This dehumanization worked both ways. It terrified enemies and it freed the wearer from normal human hesitation. When you can't see your own humanity reflected back at you, killing becomes easier. Here's something even more intriguing that modern research has uncovered. Some Vendel helmets have small holes drilled in the masks, positioned in patterns. Initially, archaeologists thought these were for decoration or to reduce weight. But acoustic analysis has shown that these holes were positioned to enhance the wearer's hearing of specific frequencies, particularly the sound of weapons cutting through air and the shouts of battle commands. This is acoustic engineering. They were tuning their helmets like instruments, filtering out less relevant sounds and amplifying survival-critical audio. And there's a brutal historical note here. We know these helmets worked because we found them buried with warriors who clearly lived long lives. Grave goods analysis shows older warriors, men who fought in dozens of battles, buried with their heavily scarred, repeatedly repaired Vendel helmets. These weren't showpieces. They were working equipment that kept bringing their owners home alive. But the design had a significant limitation that shows the trade-offs in armor design. The full-face masks severely restricted peripheral vision. You could see forward clearly, but your side vision was compromised. In formation fighting, where you're surrounded by allies, this was acceptable. But in individual combat or chaotic melee, it was dangerous. Warriors had to develop specific head-turning habits to compensate, constantly scanning left and right with deliberate head movements rather than just eye movements. Still, the design was effective enough that it evolved directly into what we now recognize as Viking helmets. Though, contrary to popular belief, Vikings never wore horned helmets. That's a myth. But what they did wear was based on this Vendel foundation. However, while European warriors were adding face masks and crumple zones, civilizations in Asia were taking a completely different approach to head protection, one that involved materials that sound too advanced to be ancient. Helmet 6, the Chinese lamella helmet. China, Tang Dynasty, around 700 CE. While European metalworkers were still hammering out bronze and iron, Chinese craftsmen were binding together small iron or leather plates called lamellae to create helmets that were simultaneously stronger and more flexible than anything being made in the West. Here's why this design is mechanically brilliant. Each lamella, small, rectangular plate, was connected to its neighbors with leather cord, wire, or silk thread. This created a helmet that could flex and absorb impacts like scale armor, but with a crucial difference. The plates were larger and overlapped more extensively, providing better coverage with fewer weak points. When a weapon struck a lamella helmet, the impact distributed across multiple connected plates, with the flexible connections acting as tiny shock absorbers. But here's the innovation that modern body armor designers have rediscovered. The lamellae weren't all made from the same material. Chinese armors would alternate iron plates with hardened leather plates. The iron provided impact resistance. The leather provided flexibility and reduced weight. This is composite armor design, mixing materials to get properties that no single material could provide alone. And they were doing this over 1,000 years before modern Kevlar composite armor. Now, here's a detail that shows the sophistication of Tang Dynasty military logistics. These helmets were designed for mass production and field repair. The lamellae were standardized in size and shape. If your helmet got damaged in battle, you didn't need a specialized craftsman to fix it. You just needed replacement lamellae and basic cordage skills. Soldiers could repair their own equipment between battles, reducing dependence on supply chains and armor availability. This is maintenance-forward design, building equipment that can be sustained in the field. But there's something even more intriguing about the construction method. The way the lamellae were bound created a surface texture that could actually deflect glancing blows more effectively than smooth metal. When a blade struck at an angle, it would catch on the edges of the overlapping plates and be directed away rather than sliding along the surface looking for a weak point. This is passive redirection. The armor's structure naturally guides attacks away from vulnerable areas. And here's where cultural sophistication enters the picture. These helmets were often decorated with inscriptions, family symbols, or Buddhist prayers. But these weren't just decorative. In a society where literacy rates were low and identifying individuals in battle was crucial, these markings served as identification systems. Commanders could recognize their soldiers by their helmet decorations, improving battlefield coordination. There's a survival statistic that's remarkable. Archaeological evidence from Tang Dynasty battle sites shows that soldiers wearing lamellar armor had significantly lower rates of lethal head wounds compared to soldiers in solid metal helmets. The flexible, energy-absorbing properties genuinely saved lives at measurably higher rates. But the design had one critical vulnerability: fire. The leather cord and leather lamellae could burn. An enemy with flaming arrows or fire-based weapons could compromise lamellar armor in ways that solid metal helmets would resist. Chinese military texts from the period actually include specific instructions for combating fire-based attacks when wearing lamellar armor, including emergency removal techniques and water-soaking protocols before battle. Yet the design was so effective that it spread across Asia, from Japan to Mongolia, from Korea to Central Asia. Each culture adapted it to their needs, but the fundamental concept remained: small, connected plates providing flexible protection. However, another Asian civilization was developing something even more remarkable: a helmet that incorporated precious metals not for decoration but for genuine protective advantages. Helmet 7. The Japanese Tsunari Kabuto. Japan, Sengo period, 1467 to 1615 CE. An era of constant warfare, where samurai culture reached its peak and armor design became both art and life-saving technology. The Tsunari Kabuto, the head-shaped helmet, represents the culmination of centuries of Japanese metallurgical expertise. Here's what makes this helmet design revolutionary: riveted plates arranged in a hemispherical bowl that distributed impact force so efficiently that modern crash helmets use the same basic geometry. But let's unpack the specific engineering that saved lives. The Tsunari Kabuto was constructed from multiple curved iron plates riveted together along raised ridges. These ridges, called taithagi, weren't decorative. They were structural reinforcements that prevented the bowl from collapsing inward under impact. When struck, the force would travel along these ridges to the base of the helmet, where it would dissipate into the wearer's shoulders and torso rather than crushing down into the skull. This is load path engineering, deliberately designing how forces will travel through a structure. Now here's the detail that shows incredible material science understanding. Japanese swordsmiths applied differential heat treatment to these helmet plates. The outer surface was made harder to resist penetration. The inner surface was left softer and more flexible to absorb shock. This is the same principle used in Japanese swordmaking: hard edge for cutting, flexible spine for strength. But they were applying it to armor, creating a two-layer defense in a single piece of metal. And there's something even more sophisticated about the overall design. The helmet bowl sat on a padded liner called the yukbari, but the genius was in how it was suspended. The bowl didn't rest directly on your head. It floated above it, held in place by the liner system. This created an air gap, ancient crash protection. When the helmet got struck, it could move slightly on its suspension before hitting your head, absorbing some of the impact energy in that movement. Modern motorcycle helmets use the exact same principle, and they're just rediscovering what Japanese armorists knew 500 years ago. But here's where the Tsunari Kabuto goes beyond pure function into psychological warfare. Many helmets featured elaborately decorated frontal crests called Maydate, golden horns, family crests, or mythological symbols. But these weren't just identification or intimidation. They served a practical purpose, making the wearer appear taller and more imposing, which in close-quarters combat could provide a psychological edge. And in a culture where honor and reputation were everything, being recognized on the battlefield by your distinctive helmet could mean the difference between being taken prisoner for ransom or being cut down as an anonymous soldier. Now here's a detail that reveals the economic reality of Japanese warfare. The quality of your Tsunari Kabuto indicated your status. High-ranking samurai had helmets with dozens of precisely crafted plates, intricate lacquering, and gold inlay. Lower-ranking warriors had simpler versions with fewer plates. But here's what's remarkable. Even the simplest versions incorporated the fundamental protective geometry. The Japanese understood that basic safety shouldn't be a luxury. The hemispherical bowl design that distributed force was standard across all quality levels. And there's battlefield evidence that proves effectiveness. Many surviving Tsunari kabuto show damage from multiple impacts, deep cuts, dents, even musket ball strikes, but they're intact. They didn't fail. The warriors who wore them survived to fight again, which is why the helmets still exist in museums today. But the design had one interesting limitation that shows the trade-off between protection and practicality. The Tsunari kabuto was heavy, typically 2 to 3 kilograms, which doesn't sound like much until you wear it for hours during a battle. The weight caused neck strain and fatigue, which could slow reaction times. Japanese warriors trained specifically to build neck strength to handle extended helmet wear. This is adaptive physical training, modifying your body to match your equipment rather than the other way around. Yet despite the weight, the design remained popular for over 400 years, evolving to accommodate gunpowder weapons without abandoning its fundamental protective geometry. But while Asian helmet designs were reaching peaks of sophistication, warriors in the Middle East were creating something that would change the entire concept of head protection. A helmet that was also a psychological weapon of unprecedented power. Helmet 8. The Mamluk Turban Helmet. Cairo, 1300 CE. The Mamluk Sultanate controls Egypt and Syria, and their warrior elite, former slave soldiers who became the ruling class, are wearing helmets that would confuse modern observers. They look like turbans. Elaborate, wrapped cloth turbans. But they're solid steel. Here's the genius that most people miss. These helmets disguised their protective nature. The turban helmet, also called the Qud, was constructed from steel-shaped and decorated to resemble wrapped cloth. The surface was etched, engraved, and sometimes inlaid with gold or silver in patterns that mimicked fabric folds. But underneath the decoration was a solid steel shell that could stop a sword strike or deflect an arrow. But why disguise it? Here's where military strategy becomes fascinating. In Islamic culture, the turban was a symbol of status and religious devotion. A warrior wearing an obviously military helmet was just a soldier. But a warrior wearing what appeared to be a turban? He was a leader, a religious figure, someone important. This created tactical advantages. Enemies would prioritize attacking obvious military targets while potentially underestimating someone in just a turban. And allies would rally to visible leadership symbols even in the chaos of battle. Now here's the engineering detail that shows sophisticated metalworking. The helmet had to be shaped thin enough to actually look like wrapped cloth from a distance, but strong enough to stop weapons. Mamluk metalworkers achieved this through a technique called selective hardening, heating and cooling different areas of the steel to create zones of varying hardness and flexibility. The crown was hardened for impact resistance. The sides were left slightly softer for some shock absorption. And the entire surface was worked to be thinner than typical helmets but compensated with superior material quality. But there's something even more intriguing about the design philosophy. The turban helmet included a mail aventail, chainmail that hung down to protect the neck and shoulders. But this wasn't attached permanently. It could be removed for ceremonies or non-combat activities. The helmet was designed for dual purposes: combat protection and formal wear. This is multifunctional design, creating equipment that serves multiple social roles, not just military ones. And here's a cultural detail that shows the intersection of faith and warfare. Many turban helmets were inscribed with Quranic verses on the interior surface, invisible when worn but present as spiritual protection. Warriors believed that both the physical metal and the holy words protected them. From a modern psychological perspective, this provided a morale boost. The belief that you had both technological and divine protection could make warriors more confident and effective in combat. Now, there's battlefield evidence that these helmets genuinely saved lives in surprising ways. Because they were less obviously military, warriors wearing turban helmets were sometimes able to move through civilian areas or approach enemy positions without immediately being identified as combatants. This created reconnaissance and surprise attack opportunities that solid military helmets wouldn't allow. The disguise was itself a form of protection, not just physical but tactical. But the design had a crucial limitation that reveals the constraints of trying to serve multiple purposes. The thin metal required to mimic cloth couldn't handle the same level of impact as thicker, dedicated combat helmets. A direct strike from a heavy weapon, a war hammer or heavy mace, could deform or penetrate a turban helmet more easily than it would a thicker Roman or Japanese helmet. The Mamluks compensated for this with superior combat training and tactics that emphasized avoiding direct heavy impacts, but the vulnerability existed. Yet the design proved successful enough that variations spread across the Islamic world, from North Africa to Persia to Central Asia, each region adapting the concept to local artistic styles and combat needs. However, one more civilization created a helmet design that pushed protective technology to perhaps its absolute limit before gunpowder changed warfare forever. And surprisingly, it came from a culture most people don't associate with advanced military technology. Helmet 9. The Saxon Pioneer Helmet. England, 7th century CE. Long before the Norman conquest, before the stereotypical image of knights in shining armor, Saxon warriors were creating helmets that modern archaeologists call ridiculously sophisticated for their era. The most famous example, the Coppergate helmet, found in York, features something that shouldn't exist in 750 CE. A fully articulated nose guard that could be raised or lowered depending on combat situation. But here's why this specific feature saved lives in ways other designs didn't. The movable nose guard meant warriors could protect their faces during active combat but raise it immediately afterward for better breathing, drinking, or communication. This sounds simple, but consider the tactical advantage. In prolonged battles or sieges, warriors in fixed face guard helmets had to choose between protection and basic human needs. Saxon warriors with articulated nose guards could quickly adapt. After a combat exchange, flip up the guard, catch your breath, take a drink, assess the situation, then flip it back down when the next wave came. This is adaptive battlefield technology, equipment that responds to changing needs within the same engagement. Now here's the engineering detail that shows incredible craftsmanship. The nose guard was attached with a hinge mechanism that remained reliable even when the helmet was dented, dirty, or damaged. Medieval metalworkers achieved this by using a simple but robust pin and bracket system that had minimal points of failure. The pin was slightly loose, allowing for easy movement, but the bracket was tight enough to hold the guard in position when raised or lowered. This is reliability engineering, designing for real-world conditions where perfect maintenance isn't possible. But there's something even more remarkable about Saxon helmet construction. They used a technique called pattern welding to create helmets from multiple types of iron with different properties. Softer, more flexible iron formed the base. Harder iron was welded on as the outer surface. This created a helmet that could absorb impacts without shattering but resist penetration without denting. It's composite construction, centuries before the term existed. And here's a detail that reveals the sophisticated metallurgy. Pattern welding creates distinctive patterns in the metal, wavy lines and swirls where different iron types meet. Saxon helmets often displayed these patterns prominently. Why? Because they were proof of quality. A warrior could look at a helmet and immediately assess its construction method and, therefore, its protective value. The pattern was a certificate of authenticity and quality built into the metal itself. Now, there's archaeological evidence that shows how effective these helmets were in the brutal reality of Dark Age warfare. We've found Saxon skeletons with healed head injuries, deep cuts to the scalp that struck bone but didn't penetrate the skull. These injuries show the distinctive pattern of sword strikes that hit helmets, deformed them, but didn't break through. The warriors survived, the wounds healed, and they fought again. These weren't lucky hits. These were helmet designs performing exactly as intended, redirecting and absorbing blade energy that should have been fatal. But here's where it gets historically interesting. Saxon helmets were rare. Very rare. Most Saxon warriors fought without head protection because quality helmets were extraordinarily expensive. Only nobles and elite warriors could afford them. This created a battlefield visibility problem. If you were wearing a helmet, you were obviously someone important, making you a priority target. The protection came with a price, increased enemy attention. Yet those who wore them survived at dramatically higher rates. Burial analysis shows that warriors buried with helmets lived, on average, significantly longer than those without. The investment paid off in survival. However, the articulated nose guard had one mechanical vulnerability. The hinge mechanism, while reliable, could still be targeted by clever enemies. A precise strike to the hinge could jam or break it, leaving the nose guard stuck in either the up or down position. Saxon warriors had to protect their helmet mechanisms almost as carefully as their bodies, adding an extra layer of defensive awareness to combat. Still, the design influenced helmet development across Europe for centuries, with movable visors and articulated face guards becoming standard in later medieval armor. But there's one more ancient helmet design we need to examine, one that takes us to the southern hemisphere, to a civilization that most people don't even associate with metal armor. Helmet 10, the Mesoamerican wooden helmet. Mesoamerica, Aztec, and Maya civilizations, 1200 to 1500 CE. When most people think of ancient helmets, they think metal, bronze, iron, steel. But in Central America, warriors were creating head protection from materials that seem impossibly inadequate: wood, leather, and quilted cotton. And yet, here's the paradox. These helmets saved lives against weapons specifically designed to defeat them. Let me explain what seems impossible. Aztec warriors wore helmets carved from solid hardwood, often shaped to resemble animal heads, jaguars, eagles, skulls. The wood was dense tropical hardwood, sometimes lignum vitae, which is literally one of the hardest woods on Earth. So hard that it sinks in water. So hard that it was later used to make ship propeller bearings in the Age of Sail. But here's the crucial question. How does wood stop a weapon? The answer is in understanding Mesoamerican weapons. The primary weapon was the macuahuitl, a wooden sword embedded with obsidian blades. Obsidian is volcanic glass, sharper than modern surgical scalpels, but also brittle. When an obsidian-edged weapon strikes hardwood, the obsidian chips or shatters before the wood fails. The helmet material was harder than the weapon material. This is materials-based defense, choosing protective materials specifically to counter the attack materials you'll face. Now here's where the design gets even smarter. The wooden helmets weren't carved smooth. They featured ridges, protrusions, and deliberate angles that would catch and deflect obsidian blades. When a macuahuitl struck at an angle, which is how most strikes happen in real combat, the blade would hit these ridges and be redirected away from the head. The obsidian would shatter against the hardwood angles, dissipating its cutting power. This is geometric defense, shaping armor to control how weapons interact with it. But there's something else these helmets did that metal helmets couldn't. They were lightweight. A full wooden helmet weighed a fraction of what a metal helmet weighed. In the hot, humid climate of Mesoamerica, this was a survival advantage. Heat exhaustion killed warriors as readily as weapons did. A soldier who could fight longer without overheating had a genuine tactical advantage. European conquistadors, arriving in full metal armor, famously suffered from the heat, while Aztec warriors in wooden helmets could fight for hours. And here's a detail that shows sophisticated understanding of trauma. Beneath the wooden shell, warriors wore padding made from quilted cotton soaked in brine and then dried. This created a salt-hardened cushion that absorbed impact energy. When a blow struck the helmet, the force transferred through the wood into this padding, which compressed and absorbed the shock. Modern foam helmet liners work on the exact same principle: crush on impact to absorb energy. The Aztecs were using compression absorption technology 500 years before modern crash helmets. Now, there's something psychologically powerful about these helmets that goes beyond mere protection. The animal-shaped helmets transformed warriors into mythological creatures. A line of jaguar-headed warriors advancing wasn't just frightening, it was supernatural. In a culture where warfare had spiritual dimensions, where battles could be fought to capture prisoners for sacrifice rather than to kill, looking like a divine animal gave both morale boost to allies and terror impact on enemies. The helmet was simultaneously protective equipment and psychological weapon. But here's the limitation that eventually contributed to Mesoamerican defeat against European invaders. Wood doesn't stop metal projectiles. When Spanish conquistadors arrived with steel swords and crossbows, the material advantage flipped. Steel blades could cut through hardwood. Metal crossbow bolts could penetrate wooden helmets. The same material-based defense strategy that worked perfectly against obsidian weapons failed against metal ones. This is the tragic reality of arms races. What saves your life against one type of weapon might be useless against another. Yet archaeological evidence shows that even against Spanish steel, these helmets provided some protection. We found wooden helmet fragments with deep cut marks that didn't go all the way through. Warriors survived initial encounters with Spanish weapons precisely because their helmets, while not impervious, bought them crucial seconds to respond, retreat, or counterattack. And there's one final detail that speaks to the sophistication of Mesoamerican armor making. The helmets were often decorated with feathers, jade, and gold, not randomly, but in patterns that indicated rank, achievement, and warrior society membership. This served a practical battlefield purpose: instant visual identification. Commanders could see at a glance who was where, which warrior societies were engaged, and where to direct reinforcements. The decoration was communication technology. These wooden helmets represent perhaps the most perfect example of adaptive design in ancient armor, taking available materials, understanding the weapons they'd face, and creating protection that worked within those constraints. From the bronze-faced Greek hoplites to the jaguar-headed Aztec warriors, from the scale-armored Persians to the turban-disguised Mamluks, These 10 helmet designs share something profound. They represent humanity's desperate, brilliant attempt to protect the most vulnerable part of our bodies using whatever materials, whatever knowledge, whatever technology we had available. Each design saved lives. Each design reflected deep understanding of metallurgy, physics, human anatomy, and psychology, often centuries before these fields would officially exist. Warriors across cultures and centuries, working with limited resources and technology, created solutions that modern engineers study and sometimes can barely improve upon. The story of ancient helmets is ultimately a story of survival, innovation, and the lengths humans will go to protect each other in the worst circumstances imaginable. These weren't just metal hats. They were the difference between going home or being buried on the battlefield. If you found this documentary valuable and want to see more content exploring the brilliant technology of ancient warfare, please consider subscribing. Thanks for watching.